to identify characteristics a circuit which can be used to get readings for an NPN transistor can be taken as follow. Right. අපි මේක මෙහෙමයි කරන්නේ. මෙතන power supply එකක් VBB කියලා තියෙනවා. මේ power supply එක change කරන්න rheostat එකක් මෙතනින් අපි use කරලා තියෙනවා. So we need to get the rheostat. Okay. So therefore we need to use this type of case. Then අපි මෙතනින් යන කරන්ට් එක මොකක්ද කියලා බලන්න මයික්‍රෝ ඇම්පියර් රේන්ජ් එකේ තියෙන මයික්‍රෝ ඇමීටර් එකක් use කරනවා. So we are using micro ammeter, right, to get the current. And also we are using then we have to use the NPN transistor now. NPN transistor use करते. So in NPN transistor, this is the base, this is the emitter, this is the collector, right? So we are using the common emitter configuration, right? So we need to find the voltage between V and E. Therefore, we need to take the voltmeter which having the highest resistance, right? Then we are using the milliammeter to get the readings of the IC. So I will mark the current IC coming towards this, IB coming to this, then IE going towards this, right? So we not taking the IE after what, right? Then we are taking the measurement using the voltmeter. This is to identify VCE. We are using this voltmeter. VCE, VBE. Right. Then we get configurations ටික තමයි ඔය තියෙන්නේ, right? Configurations ගන්න විදිහ තමයි තියෙන්නේ. දැන් ගන්න අපි මේ හදාගන්න විදිහ circuit එක හදාගන්න විදිහ. Then it is connected to the rheostat. Why? We have to use another power source that called VCC. This is higher than this. So potential divider එකක් විදිහට අපි use කරනවා කවුද? Rheostat එක. Rheostat එක අපි use කරන්න පුළුවන් potential divider. We can use the rheostat, right? So this is the configuration. So I will take it as S1, so R1, so R2, S2, then this battery as X, this battery as Y. So we are using this type of circuit to identify the characteristic curves, right? We can change this voltage, then we can change the VBE, then we can measure the IB, right? Then we can take the input characteristic. Input characteristic given VBE, VBE and IB. Then the transfer characteristics, we can change this one IB we can change it using rheostat. Then IC IC we can measure it using the milliammeter, right? We are not using this one, right? So output characteristic, transfer characteristic can be taken using the discrete in and discrete in, right? IC and IB. So the output characteristic means VCE and IC. We can use this one, then we can change the VCE and then we can find the IC, right? That is the method. Okay, right? Okay. Know this one. I normally use currently 0 to 100 microamperes. The use of this one is measuring the IB. IB measure karaganna. So we are using this one to measuring IB. Using this one to measuring VBE. Using this one to measuring IC. Using this one to measuring VCE. Right. So these are the in-between transistors. Then write down input characteristic. Number one, input characteristic. Number one, input characteristic. So how can you find out the input characteristics? We can change this R1, then we can change the VBE, then we can find the IB using the microammeter, right? Okay, write down. In common emitter amplifier, input is taken to be the potential at base relative to the emitter in brackets, potential at base relative to emitter brackets වල දාන්න VBE. The way the input current IB varies with VBE. Given by the input characteristics. එතකොට මේකේ වෙලා තියෙන්නේ මොකද්ද? what is the proceeding? VBE changing mean we are changing the potential of B and E. Then we find the IB. So the B and E is the PN junction. PN junction එක voltage එක වැඩි කරලා IB change වෙනවා. කොයි වගේ diagram එකද දෙන්නේ? අර අපේ PN diagram වල අපි discuss කරපු diagram එකක් තියෙනවා. මෙන්න මේ වගේ එකක් තියෙන්නේ. VBE change කරද්දී IB change වෙන විදිහ මේ ඇවිල්ලා මොනවා වගේ diagram එකක් තියෙන්නේ. This turns is new voltage. Right? IB කියලා කියන microampere range එකේ this is what? Right? ඊළඟ by input characteristic. When obtaining this characteristic, the collector potential relative to the collector potential relative to emitter, collector potential relative to emitter in bracket VCE, in bracket VCE is kept constant, is kept constant by adjusting variable resistor, R2, variable resistor, by adjusting variable resistor R2, variable resistor R2. VCE can be maintained, VCE can be maintained at a constant value, at a constant value, at a constant value in the range, in the range 0 to 6 volt, 0 to 6 volt, 0 to 6 volt, 0 to 6 क्या मिलेंगे? VBE can be varied by varied, VBE can be varied by varied, by varied R1, R1. The relevant readings can be the relevant reading of VBEN, IB, VBEN, IB can be read from voltmeter, can be read from voltmeter V1 and microammeter mu A, microammeter mu A. අර ලෝගෝ එක දන්නවනේ microammeter V1 එකයි microammeter. Using those readings, the following diagram can be represented. The following diagram can be represented. So the diagram is like this. So this is diagram, right? So this is diagram. So this diagram is similar to the diagram of the anode, diagram of the diagram, right? That ticket diagram එක වගේ තමයි, right? දාගන්න මේකට කරන්න. This diagram is the characteristic of forward bias in PN junction, forward bias in PN junction. PN junction. It can be seen the curve. It can be seen the curve. It can be seen from the curve. Up to the value 0.7 volt. Up to the value 0.7 volt. of VBE of VBE 0.7 volt of VBE comma IB comma IB comma IB is almost zero, is almost zero, and beyond that IB increases rapidly. IC increases rapidly with linear path. With linear path. Okay, then we have to talk about the write down number 2, transfer characteristic. Transfer characteristic. So transfer characteristic mean we are changing the IB and measuring IC. The transfer characteristic IB කියලා කියන්නේ microampere range එකේ, IC කියලා කියන්නේ milliampere range. When there is no current in IB, that can be happen there is current in the IC. IB කියන එක න 0 වෙලා IC කියන එක න වෙන්න බෑනේ, port bias වෙන්න බෑනේ. එතකොට මෙතන එක range එකක් වෙනකම් පොඩි current එකක් විතරක් යනවා. After that, when we increase in IB further values වලින් කියනවා නම් 5 microampere වල ඉඳලා වගේ increase කරනකොට මෙයා ඔන්න ඒ විදිහට increase වෙනවා. right, ඊට පස්සේ 100 microamperes වගේ යනකොට ඔය විදිහට දිගටම increase වෙලා. This is the linear part. So what is the gradient of this one? So how can we find the gradient? Gradient is tan theta IC over IB. That mean what? IC over IB current gain. So this is IC equals beta IB, right? Because of that, this is the linear part, linear part. Then after this, all the carriers are coming to the action, so there is no any other charge carriers, this one gets saturated. So this is the saturated current. So this one is IC max. So when we considering the regions, so this is cutoff region. So this is active region. So this is saturation region. එතකොට මේකෙදි in this cutoff region IC smaller than to beta IB. This is IC කියන එක න sorry greater than. මෙතනදී beta IB කියන එක න වැඩි වුණාට beta IB කියන එක න වැඩි වුණාට IC කියන එක න අඩු. Right. This is the characteristic which shows the characteristic which shows the variation of output. Which shows the variation of output IC, variation of output IC with the variation of input, with the variation of input, with the variation of input IC, IB using the circuit that shown above. IB varied with VBE, with help of R1, VBE with help of R1, and the same time keeping VCE constant, with VCE කියන කෙනා constant, VBE කියන කෙනා තමයි vary කරන්නේ. එතකොට IB කියන කෙනා vary වෙනවා. ඒ වෙලාවේදී VCE constant කරගෙන තියෙනවා R2 constant තියාගෙන. Keeping VCE constant with help of R2, then IC is plotted against to IB. IC is plotted to IB versus IB. Right? Draw this one. So this is the transfer characteristic. When IB equals 0, IC takes a very small value close to the 0. Sometimes we body current consider, right? In the linear part of the curve, IC varies in direct portion. Direct proportion with IB. කියන්නේ මෙන්න මේක. When IB increased beyond point of saturation, this one, right? Point of saturation. Point of saturation. On curve, VCE comes to very low value. Therefore, it is not possible to keep, therefore it is not possible to keep VCE constant. Constant. When the region VCE smaller than the VBE, get a saturation region, is the saturated state. Is the saturated state. Saturated state of transistor. Saturated state of transistor. After that state is reached, after that state is reached, IC remains constant. IC remains constant. Even IC remains constant. Even IB increased. Even IB increased. The portion of linear path is called active region. Is in active region. Active region. The transistor is operated in this region. To make it works as an amplifier. To make it works as an amplifier. There are change in IB. Which is of order microampere, which is of order microampere, is amplified to change which is of the order milliampere in IC. Okay, then write down number 3, output characteristic. So what are the output characteristics? We have to change the VCE. Then we have to find the IC. IC in milliampere range, VCE in voltage. So when IB, the මෙතනදී අපිට VCE change කරන්න කලින් IB change කර යන්න ඕනේ. IB නැත්තම් වැඩ කරන්නේ නැහැ. IB දෙන්නම් VBE change කරන්න ඕනේ. එතකොට අපේ මේ first අර පළවෙනි තිබ්බ resistant එකෙන් R1 වලින් change කරන්න ඕනේ VBE. එතකොට IB හම්බ වෙනවා. IB වලින් පස්සේ VCE balance කරලා තමයි අපිට මේක හම්බ වෙන්නේ. right? එතකොට first case එකේදී අපි බලනවා මේ IB කියන එක න 0 තියාගන්නවා නේ කියලා. පොඩි කරන්ට් එකක් යනවා. මේක වැඩක් නෑ. හරිද? 0 microampere. ඊළඟට මේකේ පොඩි කරන්ට් එකක් යනවා. පස්සේ 10 microampere වලින් වගේ දානකොට VCE change කරද්දී when we change the VCE IC getting the constant value. IB 10 microampere. Right? Then when I change the R1 කියන එක නම් බලන්න change කරනවා. ඊට පස්සේ බලනවා අපි IC මේ VCE change කරලා IB මොකද වෙන්නේ කියලා. Right. So IB කියන එක නම් 20 microamperes වලට දානවා. ඊට පස්සේ IB කියන එක නම් 30 microamperes වලට දානවා. IB කියන එක නම් 40 microamperes වලට දානවා. IB කියන එක නම් 50 microamperes වලට දානවා. කොහොමද කියලා IB goes to the saturation region. Therefore, this is in this case this is the cutoff region. So regions. This one is cutoff region. This is active region. In portion where this one in this area, this is the saturation region. So this is the representation, right? Correct. Again, yanda අපි ඒක මේ ගියාගෙන යනවා. This characteristic shows the variation of output current, variation of output current IC with output voltage VCE when VBE right? When VBE is kept relevant constant value. And keeping VBE constant with the help of VBE constant with the help of R1 and varying R2 the relevant value varying R2 the relevant value VCE and IC measured. Okay, draw this diagram. Ini lihat ini cutak variation ini. When the variation of IC with VCE keeping IB equals 20 microampere in a certain value, in a certain value, in a certain value, using the R1, using R1, the each graph can be obtained, the each graph can be obtained in each IV value, in each IV value, in each IV value, in each IV value, it is seen from these curves, it is seen from this curve. IC becomes constant after, IC becomes constant after some small value, some small value, some small value of VCE, of VCE. Then IC becomes saturated. Then IC becomes saturated. IC becomes saturated. When IB equals 0, when IB becomes 0, respective value IC also becomes 0. Also becomes 0. හරි. ඊට පස්සේ මේ ඊළඟට යන්න අපි